This is the quiz review for the quiz we're having on Friday, November 2nd. It's going to cover sections 2.5 and 2.6 from the book. Since we didn't have time to do a thorough review today, I'm going to do it on this audio, and you are to be commended for at least pulling up the audio, because I'm going to go through every question on the quiz, only changing the numbers around slightly so that if you take good notes on what I'm about to present, you will have no trouble at all on the quiz tomorrow. I guarantee it. Okay, so let's get started. Question number 1 on the quiz has nothing to do with triangles. It has to do with the idea that if you have a complex solution to a polynomial, then its complex conjugate is also a solution. So question number 1 deals with the idea of complex conjugates are also solutions. So if I have a non-real solution A plus BI, then the solution A minus BI is also a solution. The question on the quiz will look like this. Suppose that X equals 3 plus 2I, then name another solution. I do give you the hint to think complex conjugate. That means if 3 plus 2I is a solution, you should write down 3 minus 2I in the blank. That's the complex conjugate, and you will have the answer correct to number 1. Question number 2 deals with the fundamental theorem of algebra that basically says that if you have an nth degree equation, so x to the nth power, then there are n solutions. But that doesn't mean that you're necessarily going to have n x-intercepts, or for that matter, n distinct solutions. Two things can happen. First of all, some solutions may be non-real. So you won't have an x-intercept if a solution is non-real, such as the 2 up above in question number 1. The second reason that you may not have n x-intercepts is some may be repeated. They may have a multiplicity greater than 1. So you may not have n distinct solutions, and you may not have n x-intercepts because of these 2 reasons. If you have those 2 reasons in your notes, you will be able to answer the question number 2. Sound good so far, right? The next question is a multi-step problem, and it refers to a function. And I'm going to give you an example function, and we're going to have to find all of the solutions to it. So let's suppose I have the function x cubed minus 3x squared plus 3x plus x minus 3. Sorry if you had to erase your notes. First question that I'm going to ask tomorrow on the quiz. So this is question number 3. First question, what is the degree of this function? I think it's pretty easy to see that the degree is 3. And the reason it is 3 is because the leading term's degree is 3. That becomes the degree of the whole function. Question number 2 asks, how many solutions are there? Well, the fundamental theorem of algebra says that if you have a degree 3 equation, then there are indeed 3 solutions. Yes, some of them may be non-real, some of them may be repeated, but they are solutions nonetheless. So when I ask how many complex solutions are there, real and non-real, please put down the same answer you put in A, because that's what the fundamental theorem of algebra says. Now, what is the minimum number of real solutions? As you know, non-real solutions could either be 0 or 2, but there's got to at least be 1 real solution to this equation. Again, if there were 2 or 0, then you would have 3 or an odd number of non-real solutions, and that can't happen because of the complex conjugates. They always come in pairs, so there's got to be 1 real solution to this. And the other reason you know that is because graphs are continuous. And if you start down here, You've got to cross the x-axis at some point because it's a cubic equation, and cubic equations look like that. They don't start and finish on the same side like even solutions. This question would be 0 if it were an even even degree equation, but because it's odd, 3, there's got to be one real solution. Now, part D is a little bit more complicated. I ask you to either graph the equation or to use the rational roots theorem to determine what that one real solution's got to be. So let me erase this quickly and put up the graph. I've used my graphing calculator to plug in the graph. Be sure to use parentheses if you need them. Oops, I put down the entire equation. So let me just graph it. And that's what the graph looks like. And you can look at the graph and you can see that it looks like it crosses at x equals 3. If you want to use the rational roots theorem, the rational roots theorem suggests that if we look at the constant term, 3, and factor it all the ways you can factor 3, which is 1 and 3, and divide that by the leading term's coefficient, which is 1, and consider plus or minus, the rational roots are either plus or minus 1 or plus or minus 3. 3 makes sense, so the answer to D is x equals 3. Next question. I'm going to ask you to use either polynomial or synthetic division to factor out the term x equals 3. So let's go through and do that. First thing we do is I'm going to use synthetic division and copy down the leading the coefficients 1, -3, 1, -3. Now, when we divide, the factor is x minus 3. We need to reverse that minus 3 and put plus 3 in here. Notice since x equals 3, that's what goes in there. It's what x equals is what we're going to divide by synthetically. Or when you look at the factor, since we're dividing by x minus 3, we're reversing the sign of the minus 3. Put plus 3 in there. Bring down the 1. I'm just going to go through and work it. If you do not understand what I just did here, please let me know tomorrow before the test starts. This becomes plus 1. That's our remainder. That's plus 0x, and that is 1x squared. Our remaining polynomial is x squared plus 1. Now, part F asks you to find all of the solutions to the equation. One solution from part D above is x equals 3. That is one solution to it. The other solutions we can get by either using the quadratic or just set x squared plus 1 equal to 0, and we see that x squared equals -1, so x equals plus or minus I. Notice we got the complex conjugate because the square root of -1 is I, and when we take the square root we have to consider positive and negative. So when you reduce your equation down to x squared plus 1 and you set that equal to 0 to find the other solutions, we get the imaginary number plus and minus I. If you go back up and look at your graph, you'll see that that makes sense because if you see the local min and max occurs below the x-axis, the other two solutions are not real. They are non-real solutions. The final question on the quiz, it's only 4, asks you to find the x-intercepts and the y or the vertical asymptotes for a rational expression. So I give you a rational expression like this. R of x, actually I say f of x on the test or quiz, but that's not a big deal, equals x squared minus 16 over x squared minus 6x plus 5. The first step to finding the x-intercepts is you've got to factor this because it's in quadratic form and we need to do a linear factorization. The numerator is the difference between two square numbers, x squared and 16, so it factors into x plus 4, x minus 4. The denominator factors, a little trickier, but not too bad. It's x and x because it's a minus sign on the middle term, the linear term, and positive on the constant. Both of these are minus, and you'll see it factors 5 and 1. Now that you've factored your rational equation, it's easy to see where the x-intercepts are. The x-intercepts occur when the numerator equals 0. Please put this in your notes. And in this case, it is when x equals -4 and x equals 4. So that is the answer to your x-intercepts. When x is 4 and -4, it will cross the x-axis. For the vertical asymptotes, now we look at the denominator. And when the denominator equals 0, that's when we're going to have a vertical asymptote. In this case, the denominator equals 0 when x equals 5, x equals 1. Now, to be thorough, we should consider the case where these two sets of answers overlap or yield the same number. Because if they do, they are neither x-intercepts nor vertical asymptotes. If you will, they sort of cancel out each other out. They do form a discontinuity, but it is a point discontinuity. That point just won't exist on our graph. And it's not defined because you'd be dividing by 0, but it doesn't create a vertical asymptote. In this case, our x-intercepts are -4 and 4. Our vertical asymptotes are x equals 5 and x equals 1. There is no overlap, so we are finished. If you were to graph this, you would end up with a graph that sort of makes sense. I am not going to ask you for the end behavior on this. I'm going to save that for another day because I think this is a long enough quiz. But that's the quiz, and good luck tomorrow. And if you have any questions, please come by and see me before school or at the beginning of the class.